Hello everyone, we are going to start the next section, which is applying this coordinate geometry. So this is basically just the different ways we can use this coordinate geometry and go into different proofs. We're not going to do any proofs today, but ways to set up so that we could end up doing some proofs later in the future. Main thing here is we can use different variables to represent the different letters or different points on the coordinate plane. And as you can see here, we have three different ways that we can represent it. In here, we have the same, we have a PQR triangle. These are all PQR triangles. And we're having this used in just all these different variables representing different letters. We don't know where they are. But as you can look onto this one, we could see that I put it at the origin, and then that makes it a little bit easier when I put something on the origin. That's because I already know what that point is. I don't have to worry about it. I don't have to use a new term for it. That's already at 0, 0. Then over here, I put it not at the origin, I put it up here at the top. So there's 1 point on an x-axis. And then you notice that I also have it 2 times the variable or 2 times this other variable. The reason I use 2 is because a lot of times you're going to be working with this, you're going to be working with the midpoint formula. Remember what the midpoint formula is, you're going to have to divide by 2. So if you make your point double times a variable, the midpoint is just going to be that variable. So whenever we're going to have to use these things and have to use a midpoint, it's easier to make to set the original coordinate points 2 times A or 2 times B or something. So that way the midpoint is just that variable there. We're going to go into some example problems for this. Okay, so here is an example problem. What are the coordinates of the vertices of each figure? We have a square, SQRE, where one side is 2A, and the axes bisect each other. So these are really important terms of where you want to put this. So the axes are going to bisect each other. That's an important part. That means that we're going to have these things being, this would be like 1A because this is all 2A. So this is going to be half of it. All of these different points would just be different points of A. So SQRE is a square centered at the origin, and SQ is A. So S and Q are A units from each axis. The same is true for each of these different vertices. I'm going to write this all out in a second once I go through this one. Next one, TRI is an isosceles triangle where TI is 2A and y-axis is the median. So that's an important part. The y-axis is the median. That means it's going to separate up TI into 2 equal distances. Since it's 2A, I can say that this is the distance of A, 0A, and distance of A over here. So since the y-axis is a median, it bisects TI. TI is equal to 2A, so T and I are both A units from the y-axis. The height of TRI does not depend on A, so you have to use a different variable. So I'm going to just show what these variables are. This one would be A. This one would be A and negative A. You guys see what's going on here. Negative A and A, and then negative A, negative A. So this here, all these different points are the actual answer. These are the coordinates of this vertex. Here, my coordinates would be A, 0, and negative A, 0. And this one, it doesn't matter, so it's going to be 0, and I'm going to use C. So here, doesn't matter what the variable is, B, C, X, whatever, it doesn't matter. But since this one has to be A, it has to be there. And since it's a negative distance of A, positive distance of A. Alright, I'm going to give you a question for you guys to try it now. Okay, so this question says the diagram here shows a general parallelogram with a vertex at the origin here and one side along the x-axis like this. What are the coordinates of D in the middle, the point of intersection of the diagonals of the parallelogram, and how do you know? So here I'm setting this up. This is going to be 0, 0. I didn't even name it. This is going to be 2 times a, again, if I want to use the midpoint formula, and 0. This is 2b and some other variable, and 2c. Here is 2a plus 2b and 2c. And I need to find out this here. So there's two ways I could do it. I need to find out this midpoint of this line here, of AC or OB. I'm going to choose AC for this. So we're going to use the midpoint formula for this. So the midpoint formula is 2a plus 2b divided by 2, and 0 plus 2c divided by 2. I forgot to put the division sign here. So that all gets boiled down to a plus b over c. So the coordinates of this point of intersection would be a plus b and c. So this point D is the midpoint of this line, which is a plus b and c. Now I have a question for you guys based on this problem here. And then we're going to go into setting up coordinate proofs. Alright, so we can, like I said in the beginning of this video, we can use geometry and algebra to prove theorems in geometry. This kind of proof is called a coordinate proof. Now we're not going to do this proof in this lesson today. That'll be the next one. We're just going to set up what you would need to do in order to do this. Alright, so they're asking you to plan a coordinate proof of the trapezoid mid-segment theorem. Again, if I ask you, I'm going to give you the theorem. What you need to prove is the mid-segment of a trapezoid is parallel to the bases, and the length of the mid-segment of a trapezoid is half the sum of the lengths of the bases. So, two things you need to do first. Best is to draw and label a figure. Here is my trapezoid. I'm going to put it on the origin here just to make things easier, and I know things will be 0. It's a little sloppy, but this is O, R, A, P. R is 2B and 2C. A is 2D, 2C. P is 2A and 0. So this is what the ones I'm going to be working with. I use multiples of 2 because I will be working with the midpoint theorem later to find the points of M and N. So now we need to see what we need to actually prove. Again, this is something I'm going to give you on a test or something like that. So the given MN is the midsegment of the trapezoid ORIP. I need you to prove MN is parallel to OP, MN is parallel to OR, and MN is 0.5 times OP plus RA. So I need to prove that this line is parallel to this one, and this line is this plus this times 0.5. So how would I go about doing this? What things would I need to use to solve this? What you're going to need to do are 3 main things. First, you're going to need to use the midpoint formula to find the coordinates of M and N. Once I have that, you can use the slope formula to find the slope of this line, the slope of this line, and the slope of this line, and to make sure that they are parallel. That's what you need to do, making sure that all of these different slopes are parallel. Finally, you need to find use the distance formula to find the distance of this line, and this line. So this is what you would need to do to set it up. Again, you're not going to prove it, you're just setting up these problems. All right, I'm going to give you a setup problem for you now.